This video is oops, just done some anti-differentiation. I'm just going to write anti-diff now that we're comfortable with this. I'm just going to write that anti-differentiation using substitution. And this is a powerful way to anti-differentiate a lot of functions, that, expressions that we get. Basically, what it is that if you see an integral and you have some function and you've got some inside function, so it's so there's some function inside of a function. Okay, you've got that, and you also see in the expression that you need to integrate, sorry, that the differential of the inside function. Okay, there you go, something that looks like that. An example of this might be just something silly. What if you get, say, x squared, and you've got, like, say, let's say sine of x squared, and you've got that times by 2x. Can you see how in dx? Can you see how the inside function here, x squared, you can see there's the differential of that, the derivative of that, and so that's really nice. Or if you had the square root of cos x times sine x, something like that, if you're trying to find that. Now what you've got here is that you've got a function cos x inside a function the square root of, but also here you've got, so the inside function is cos x, the derivative of cos x is negative sine x, which is pretty close to sine x itself, and so there are cases where substitution is possible. So what you're looking for, look to see what the inside function is. If you also see the derivative of that inside function somewhere else in that expression, then you can use substitution. And so what I'll just show you now is just go straight into some examples of how you use substitution. So let's have a look at this. I'll go straight in and let's do something like this. Dx. So what I've got here is we're looking at, and you look at this and you go, I don't know how to differentiate it, but you go, well, we've got this inside function here. It's inside of a square. What's the derivative of that inside function? Well, it's 2x, which is fairly similar to this top line here. So the derivative of that is fairly similar. And so what we can do is make the substitution. And the substitution we do is we say let u, and for some reason it's always u, let u be equal to the inside function, which in this case is x squared plus 1. And then what we get is du dx, the derivative of that is equal to 2x. And so that's basically all we need to know. In this case we've got x up here, and so we don't want 2x, we want x, and so we can just write half of du dx is equal to x. Alright, so we just divide both sides by 2 to get that, because we want x up here. And what we do is we make the substitution. So this is equal to, and then everything in here we just substitute. So we don't want x's anymore, we want u's. So instead of writing x, we write half du dx. So let's write that. So in the top line, half du dx. That's on the top line. Looks more confusing, I know. On the bottom line, what's x squared plus 1? That's u. So we'll just have u squared on the bottom line, and we've got dx there. Now you notice we've still got dx's, but what happens is that these dx's, if you think about the dx's in like fractions, which is what they are, they're very, very, very small numbers, but they're still just fractions, they will cancel out, because one's on the bottom line, one's on the top line, they cancel out. And so what we get is just simply this. We get 1 over u squared, and that du you can just hang out the back end, du like that, and there was a half there too, and so I'll just hang that at the front. It's a constant, so I'll just chuck that out the front. And so what that does is simplify it, and we've transformed this into another integral which has the same value. And so the problem with this is that we didn't know how to integrate this. But what we've done is transform that into this, which we do know how to integrate. Okay? Because this is just half the integral of u negative 2 du, which we can integrate. So let's do that now. Let's integrate that. So that's half u, That negative 2 increases by 1 to negative 1, and we divide by negative 1. So we'll just make that negative out the front, plus c. And so that's our answer in u, but to be honest, we wanted it in terms of x. And so at this stage, we've done the integration. All we need to do is to put our value of u back in. So it'll be negative half. We'll put our u back in there, which is x squared plus 1 to the power negative 1 plus c. Now you could rearrange that. I will. Could be 1 over negative 2 x squared plus 1 plus c, something like that. That's fine either way. So the steps are: recognise that a substitution could be made because your inside function has its derivative on the top line somewhere. You let u be the inside function, find out what du dx is, and then substitute all of these things back into the original function so that you've got a function that's only in terms of u. Hopefully then you can you've got something that you can anti-differentiate, that you know the value of. Do that and then substitute x back into there. Okay, so let's just do another example of this. Example, let's do integral of cos x over sine cubed x dx. Okay, again, we don't know how to do this. We've got no idea. There's no quotient rule, there's no product rule in anti-differentiation, so we just need to figure it out. But what we do have here is something. You'll notice on the bottom line we've got a function inside of a function, because what this is sine x to the power 3. So I've got a function sine x inside of a function of that. So you've got an inside function. What's the derivative of sine x? What's the derivative of this inside function? It's cos x. And so what that means is a substitution might be a really good idea here. So let's do this. So again, we always use u. So we say let u be equal to the inside function, which is sine x. The derivative, du dx, is equal to the derivative of sine x is cos x. Okay, so now what we can do is substitute these values of u into our antiderivative. So let's do this. Top line, cos x. Cos x is du dx. So we've got du dx on the top line. On the bottom line, we've got sine cubed x, which is u cubed to the power of 3. And we've got dx. Now, that dx and that dx cancel, and so what we get is just 1 over u cubed du. We know how to anti-differentiate. Again, same thing. We do it every time. Negative 3 du, like that. And that's equal to u. That increases by 1. We divide by that number, plus c, and then we put our value of u back in. What was u equal to? It was sine x negative 2 plus c. Again, tidy that up. That'll be 1 over sine squared x. What is 1 over sine x? That is cosec x, cosec squared x. So negative half cosec x plus c. So there we go, and there's your answer. So they're the steps in using substitution. In the next video, no, I'll do it now. Just let me check my time very quickly. I promise it'll be quick. I'll do it in the next video. So that was substitution. Have a go. Next video I'll do some harder ones, and I'll show you how to do definite integrals when you're doing substitution.